Okay, dokie. Right, so this is a continuation from my live stream the other day. Now, as you may remember, in the previous live stream, I removed the relay because the contacts were carbonised up, and that was my first suspicion that the fault was with the relay. And the reason for that is because there was all this black stuff inside the relay, and it was kind of a false flag, right? The relay did need a clean. It was really bad. The contacts were terrible. But after I put this thing back together again, and after doing some checks, I discovered, after putting it back up on the, connecting it back up to my solar panel, there was no voltage coming out. And the relay, I know, I already checked that and it was fine. And I also suspected that the NE55 timer chip, this one here, was faulty, and that the relay might have been stuck in a permanent on position, which would prevent the supercapacitors from actually developing a proper charge, because it might have been draining them down. But anyway, that beside the point. The fault is not on this board, right? I later went and did some more analysis, because years and years ago I remembered something. These little boost regulators, which convert 3 volts between I think it's between 1 volt and 20 volts or more than that. It converts 1 volt to 20 volts. It steps it up to whatever voltage you want on the output, you know, which is set for about 15 volts, right? Well, it turns out that this actual module is the fault, and I've confirmed it. It's definitely true. Now, a few years ago, let's see, I actually bought more than one, and there's another one on this heatsink here. This is another one of those modules, and this one is working. So what I'm going to do today is remove the one on here, because this is just an experimental, it's just on a heatsink for doing tests and that. I've already checked it and this is working. I calibrated it already to 15 volts in the output maximum, because that's the voltage that needs to go to the regulator in my lithium battery, because my regulator in my lithium battery converts anything around 15 volts down to 12.04 volts, which is the maximum for a lithium ion battery, right? Otherwise, if you're any higher than that, you can have problems. So this basically delivers 15 volts. Now, the way these modules work is, as the input voltage drops and they're stepping up a lower voltage to a higher voltage, the actual current on the input side increases. It goes up exponentially. So it might, if it's converting, say, 12 volts to 11 volts, and if the current is around 2 amps or 1 amp, now as that input voltage drops, what happens is the current goes up and up and up and up and up. So it draws more and more current as the voltage drops on the input, because it's trying to basically make more output voltage and more output current by sacrificing the load, the current on the input. So it basically uses more and more current to get more and more out. So it's basically like one of those what do you call them? Oh, my brain's not working again. Anyway, there's these little devices that you can make to amplify low voltages and step them up into high voltage. I think I forgot what you call it. It's called something steel or something. I don't know. Anyway, I can't think of the word. Anyway, so what I'm going to do is I've got to remove this heatsink, because on this board on here there is a heatsink on the back, right? I don't know if you can see that. you look underneath, there's actually a heatsink I made for this on the base. And the heatsink is actually bonded. Oh, if in case you notice, it's still got 3.36 volts in it. Well, that's the supercapacitors, right? And that's going to go out pretty soon. There's no output. The relay's not on, so there's no actual voltage coming from the relay to this module right now. It's totally dead. The only voltage that's being measured right now is what's in the supercapacitors, and that's going to go off any minute now. So what I've got to do is unsolder this. Now, originally when I stuck this on here, I used thermal cement. Now, as it happens, thermal cement, when you get it in a tube, it doesn't have a very long life cycle. I mean, it dries up. Once you've opened it, it tends to dry up inside the tube and become cement, and you can't, it is cement, but it gets rock hard and you can't get it out. It's like dried up toothpaste. Well, you can't get it out anyway. And I'm not going to fight about ordering more thermal cement just for this job. I'm going to use some, I'll use some other thermal heat transfer compound. As it happens, I happen to have some Arctic silver. So I'm going to use some Arctic silver, and I'm going to stick that back on this heatsink. But I'll have to secure this board another means. I could either secure it with some glue, or I can put some pads underneath, some foam pads, and stick it on with glue. As long as this is in contact with the heatsink, that's all that matters. Now, I was also talking in the previous video about my polyfuses, and I must be going blind. Well, I am getting blind, because guess what? There's two freaking polyfuses right freaking here, right? At the moment, there are two polyfuses here. And now, if this thing failed because of excess current on the input, it might be because it's getting too much current. So what I can do is remove one of these polyfuses to reduce the current input by a half. Now let me just see, I can't remember now, it's years. So if you look in the description, you'll find loads of links to all the previous build I did on this when I first designed it. When I etched this circuit board, I designed an etched this circuit board, and the reason I'm explaining all this right now is because I was asked a question by Alan, a friend of mine, and I should have gone into more detail about it. But this board was purchased from eBay. This board was purchased from eBay. This timer board, I built that when I was in college, actually, many years ago, and I had it kicking about, and it just clocks the number of times that the relay has been activated. So I built this board. This is the main trigger board that I actually built, because I couldn't get something like this on eBay because it's custom. It's very, what's the word, proprietary in my design, because I needed it to work in a specific way, and I couldn't buy anything like that. The MPPT, the maximum peak power transfer circuit board, was also purchased off eBay. I actually added a capacitor to the output because this thing has some little problems with it, because if there's actually no load on it and there's no battery on the output, it turns itself off. So the capacitor is to aid the circuit to maintain and believe it's got an actual load on it to charge, otherwise it keeps turning itself off. But once the relay kicks in, it sends a voltage to the battery to charge the battery, and some of that power goes back to this capacitor to fool the MPPT circuit into believing that there's actually a load there, even though there's not always a load there. There's only a load there when this relay is off. So when this relay turns off, that's when the MPPT charger is supposed to take effect. It's supposed to pass power straight through to the battery, right, through a different relay circuit on here. But it won't do that if it thinks there's no battery there. It'll turn itself off. So some of the power goes to this capacitor, charges it up, and then the MPPT is happy, it will stay on. And as soon as the relay clicks off, then the MPPT takes over and continues to charge the battery if there's enough power flowing through it. But if the voltage drops below a certain threshold, the MPPT turns itself off, then the relay and this boost charge circuit takes over, which is a pulse charge. It only pulse charges when there's not enough sunlight. Now, also, this little board on top I actually made myself, which was to handle some issues I had with noise. It's just a filter circuit, right? Some capacitors to filter noise that doesn't actually cause this relay to artificially trigger when it's not supposed to do, because these timers, these NE555 timers, they're quite sensitive to transients, as in transient pulses on the power supply lines, and they can be false triggered by accident, you know, by interference. So that board is just to filter that out. And obviously the counter that came off eBay too. That was a eBay purchase many years ago. I actually got a few of these. One of these modules is in my battery actually. This measures the amount of current that's being sent into the supercapacitors from the solar panels. So this actually shows how much current is going into the solar panels. It doesn't measure voltage or current going out of the supercapacitors to the battery, because that's measured actually on the battery itself. You know, the battery's got a module like this as well. So anyway, I thought I'd cover all that so you can get a clearer idea of what this does. So all I've got to do is remove this thing, because this is what's gone wrong. Anyway, I should have known, because these things, I actually remembered that I'd had problems with these before. They don't last very long, especially if the loading is too high. If the input current gets too high, they just go open circuit. They just fail. I don't know if the coil itself has gone open circuit. Probably has. There's a few on eBay, but I couldn't find the original one like this on eBay. But it doesn't matter, because I've got a spare one here. It's exactly the same as that one. It's upside down probably. Yeah, it's exactly the same as that one, but this one's a bit gunked up because I put some glue on, because these trimmer ports, these little multi-turn trimmer ports, have a tendency to flop about if you push them accidentally. So I glued that in place so it wouldn't accidentally keep moving around, because it was a bit flimsy. All it's got to hold it in place is the 3 little legs, so I actually packed that with glue so it wouldn't move. Anyway, I've tested this, it works fine. So the tricky part is getting this off the heatsink, because that cement is rock hard. So what I'm going to have to do first of all is get some acetone on there to maybe get it to loosen up somehow. See if I can do that without destroying the circuit board. Right, so I'm going to squirt a bit of acetone underneath. Hopefully I can loosen this up. Oh, normally I don't have chat running, by the way. I normally don't have chat displayed on my OBS, but guess what? I've actually got it running right now, so I can actually see what's going on. So, I mean, I don't know if it shows me the chat, I have no idea. I don't normally use it because I don't get that many viewers, to be honest with you, but that's because I don't make that many videos about this stuff. And when I'm in Second Life, I don't want that on my screen anyway. I'm going to have to squirt some more, because this stuff evaporates so freaking fast. It just, as fast as you put it on, it just evaporates. So I'm hoping I can get this off now. Let's see if I can prise it up a bit. I'm going to have to get that one off as well. I don't want to break it. The boards are very thin. Let me get that hook, actually. I can find that hook. Just want a little bit of leverage underneath here. Still stuck. It's been on there for a long time, a few years. So if I can get it to lift up one corner and get some acetone underneath. That's what I'm thinking. Damn it. I'm going to have fun getting this off. I can see it coming. This thermal cement, it dries very, very, very hard. Let's see if I can get my knife underneath. Once I can get one corner, it might peel off. As you know, it's like trying to get a CPU off a computer. Yeah, it's been on there a long time. You're supposed to twist it and then pull it. That's how you get them off. Well, I can't twist this because it's absolutely rock solid. So I might have problems getting this off. It might even break the damn board. I'm hoping not, because I haven't got another one. This is... Now, the only other thing I could try maybe doing is heating this up somehow. But this is a heat sink. Now, maybe if I heated it up, if I get this acetone underneath, I'm trying to do that. I have to keep on injecting a small amount underneath because it's not budging. This cement is, well, oh, I just knocked my camera, sorry about that. I was just trying to see if it's softening a bit. Let's see if I can zoom in a bit. This might take a while. I'm trying to break the surface tension on it. I could technically wire this in with this heatsink on it directly to that board. If I can't get this off, I'm going to have to do that. I might actually have to do that. I mean, this heatsink is a lot better than the one that's on there. But it's going to be awkward fitting this on there with that massive heatsink. I mean, I'm going to have to stick this heatsink on the side. I could do that. I might have to do that because this is stuck on there really well. Now let's get this old one off first. Let's just leave that for now because I tell you, I don't know. This one is working. This one's working, and I don't want to ruin it or break it because then I'll be up the creek. Let's just get this thing off because this is going to be fairly easy to get off, I think. Because I don't have to worry about damaging it because it's already knackered. So, right, let's see. Alright, see, I have to unsolder it first. I'm zoomed in and still. Let's zoom back out. I need to be up to 350 or something. I need to put some flux on here. Make my life a bit easier. Now there's an extra red wire that goes on the bottom right side of, hang on, is that the output? Which is the output? I've forgotten now. It's been years since I worked on this, so I'm forgetting things. Let me just check. Let's just shine my light on. Yeah, the output is at the bottom, right? The input's at the top. And I can't remember now if these polyfuses, I think they're actually going on the input of this other module. Let me just check some of that in. Yeah, these two polyfuses are actually from the solar panel. Now I wonder if I could actually protect this other module, you know, one of these, the other one, with some polyfuses. Now I don't know how many of these I've got, because I can't remember now if I bought 2 or 5 or what, but maybe I could switch one of these, put one of these on the input of that this thing, so that we don't overload it, because I think that's what's happened. It's this hot weather that we've been having. It's been so sunny that it's probably got too hot. That's probably what's happened. It's been so freaking warm. Just a minute, I need to check some on my computer. I want to make sure that my live stream is going out. Seems to be. Just give me a sec. Right. That seems to be okay. Right, let's see if I can get this thing off here before this thing goes back to sleep. I might need my... I need to rest this on something because I can't get the angle right. Put it on here. That's better. I need my pliers. My tweezers are not gonna be strong enough to hold them wires. I have to get these off first, otherwise oh shit, this tip's oxidized again. A good thing I wet my sponge yesterday. I don't have to wet it again. What? Just on that wire. See if we can get this off. I might have to go up to 400. No, I've got it. Got one wire off. Right. I can't quite see the other one because this other wire's in the way. Oh. Jeez. Oh, there's something in the way. Can I move that over here? Right. Okay. I think I'm going to have to lay it on its back. Right. Right. Grab all that wire. Got that wire off. I don't know if I'm blocking your view. You get this red wire off as well. Oh, shucks, I'm nearly... Hang on a minute. Need to get the angle right. I'm going to have to use my left hand. I don't like soldering with my left hand, but yeah, I've got it. So I've got them 2 wires off. Now we just need to take the other wires off the top. I need my thing again, my prop. No, these are alright. I can easily get to these, but I just don't want to burn my fingers. Oh, do I need more light on this? I think I do. Give me a minute. Get a light. If I turn my... I've got this portable light. This should help. So you can see what I'm doing. Let's zoom in a bit. I'm going to have to go up to 400. What are we? No, I got you. Right, and the other yellow wire. Yellow is positive, by the way. I didn't have any red wire on when I built this. I had this heavy gauge wire. It was purple and yellow, and I thought, well, right, that's off. Now I can switch my soldering iron off, I think, for safety reasons, because I don't want to have an accident with it. I'll just clean the tip. That's nice and clean. Right, so now I have to get this thing out of here. Now look, my module's it's just about to turn itself off. It's virtually just discharged completely now. What the hell? Right, so now, where's my hook gone? Now this might be... Oh, this might actually come off easy. I'm not sure. It looks to be fairly loose now. I can see it moving. Don't know if the heat sink's going to come off or... Oh, it's just... Oh, I see. It's the whole... It's stuck on... I've forgotten how I did this. Yeah, it's stuck on a bit of cardboard or something. Oh, it's a bit more metal. Cool! The whole thing came off. Brilliant! Right. I didn't have to fight to get this off. So this is the one that failed. It failed probably because it got too hot. So maybe this also uses thermal cement, heatsink cement, which is really hard. So getting that off there would be probably just as hard as the other one. But I don't have to worry about destroying this one because it's knackered. So what shall I do? Shall I just fix it? Should I just mount this on here differently? Maybe I should, because let's face it, the other heatsink was inadequate. This one is probably more than adequate. I can certainly wire this one up, and I can try it out, see how it goes. Well, the heatsink's huge. I haven't got really much room on here. I could stick it on the side. No, actually, the air needs to flow up with the heatsink. So ideally, I should have put this thing on the other way around when I did it, but never mind. Ideally it wants to go like that, stick it on there. I could stick it on there like that, and then just wire it up. But the wires, these wires, oh, actually I've got quite a bit of wire there, I can move them around. So which is input? It says out on there. It says out. So that's output. Right. I need to think a minute. So input was at the top. Yeah, that's right. So input was coming from the relay, output there, up here. So this is input, that's a common ground. So we don't have to worry about that, it's common ground. This is input. So input was at the top, output at the bottom. So this one wants to be that way around. I need to take these wires off because I'm going to solder them heavy duty wires on. Let's take these wires off because they're I've turned my soldering off. Hey. Right. Let's turn it back on. I need to be back up at 400. .360 is near enough. Okay, so flux. Just putting my flux on here. I noticed the new ones on eBay, they've got little socket screw terminal things on now instead of the soldered on. They've improved them a bit, I suppose. Still, I wonder how reliable they are. It's the capacitor plague, you know. Everything that you build, everything that you get from China, not everything, but most things, it's all suffering from capacitor problems. It's a shame. I'm going to clean this off with my solders. Actually, no, I can leave that solder on there. Because I'm going to... I need plenty of solder on here anyway. I need a bit more on there. Yeah, I'm thinking about the fact that sometimes when some solder is that horrible high melt solder, it's nasty stuff. This is all lead based, so I'll just put some fresh stuff on here. Where is it going? Oh, it's going underneath. Ah, right, I need to turn it upside down. It's gone right through to the bottom. Huh, hang on. Just want to get it off, put it on the top. It wants to be on the top, not the bottom. Right, I think that's just about ready. I'm going to leave this heatsink on anyway, because let's face it, probably needs it. Right, so my device is going to get new life with a new heatsink. Okay, let's think. How am I going to mount this on here? Oh, which is input again? I've forgotten now. I can't see what I'm looking at. Right, output is at that end. So I'm just looking under my light. My short-term memory gets worse, you know. I've got a bit of wire stuck on here. Right. You know what? My memory is getting so bad. I'm just going to write it on here. Out. 0 in. So I've written it on the heatsink because I'm struggling to read the writing. It's so tiny. So that's going to make life a bit easier, less likely to make mistakes. I've just got 0 and not 0 and I. Oh shit! My soldering just turned itself off. Ah, right. How the hell am I going to mount this on here? There's not much room. I'm going to have to mount it on the side. I've got to do. But is it going to stay? These wires down here are really bloody short. Let's see. I can pull that wire out of here. Stuck on with some glue. Right, that's one wire out. I can get two there. Just move that out of the way a minute. I have to have a think about this in a minute because I want to make sure I get this right. How I'm going to mount it. Should I move it? Should I move it to the top and extend these wires? That's what I'm thinking about. I've got more of this wire. I could move the whole thing. I could move the whole bloody thing and stick it somewhere else. I could stick it on the back. Zoom out. Sorry about this, I'll keep forgetting. I could stick the thing on this. I could stick this thing on the back, right? That's what I'm thinking about. Near the supercapacitors. Why not? That way it get good airflow as well, because there's nothing. I mean, the supercapacitors themselves, they never get hot, right? They never get warm ever, because they don't deliver enough current. And I know that they can work better with a little bit of warmth. I could mount this right on the back here. That would be ideal, I think. I'm not going to cut these. I'm not going to take these wires off because there's just double soldered on this capacitor in there, and I'll probably just extend these wires. I've got some heat shrink sleeving. I think that would work. I'm just trying to think. Let's have a look. Where is it? Oh. So I've got this. I bet you I haven't got any. Oh, this is massive. Oh, there's some small stuff in there. Yeah, that'll work. Hang on. Anything else in this bag? Nope. Right. I have some heatsink sleeving. So we can extend them wires. This is the stuff. This is what I want. Right. Got anything else in here? This is for batteries, by the way. This purple stuff is for heat shrinking lithium-ion batteries. A while ago, I got some second-hand batteries, and after I removed them from the battery boxes, recycled them. Some of them were glued together, and the heat shrink sleeving on them was ripped off, and I had to recover them. I must have moved them. They're not there anymore, but I was going to show you that. What's in here? I have to go and get some wire. So you have to give me a minute. I'll find it. Right, sorry about that. Right, so I found my wire. Yellow and purple. Right. Heavy duty. Probably 5 amps or something. 10 amps maybe. I think it's 10 amps. From Farnell. The good stuff. Proper copper. I mean, such a lot of stuff from China nowadays. It's not even real copper anymore. It's magnetic. I mean, this is real copper, look, right? There's a magnet, right? There's no neodymium, look. Nothing. Because it's not fake wire. I mean, look at this stuff, right? This stuff I took off there. That's real as well. Right? But some wire that you get now, it's not proper. It's just freaking steel, tinned steel wire. It's not real wire anymore. Okay, so is anybody actually watching right now? Ideally I might quit and do a second live stream, because I just want to have a think about this. I don't want to rush it, right? Because I have to decide where I want to put this blooming thing. Do I want to put it in the back? I mean, I could, in theory, mount this in a box, but I don't have to. I just don't want my live stream to be going on and on and on, just me fighting about thinking. Anyway, let's extend these wires first. Let's just get them wires extended, because they are too short. Well, this purple one, right, let's just make these wires longer, because that's way too short. My solenoid went off, so I've got to turn that back on. 300 should be enough just for the wire. Now, is this heat shrink sleeving going to be big enough? Uh-oh, it might not be. Oh my god, it's going to be freaking close. Only just goes on. So if I get my purple wire, I can cut this wire when I get to where I'm putting it. I'm going to cut it short, but at the moment I'm just going to leave quite a bit on there, because God, it's warm. Right. Take some heat shot. I haven't got much, look. I've only got this much, so I've got to be very careful how much I use. I just want to use a small amount. God, these scissors are blunt. Right, I'll stick it on this long piece of wire, because the heat is going to shrivel it up. I don't want to shrivel it up. Right, let's just tin this. Move this out of the way. Oh, let's put some flux on here. There's splux in the solder anyway, but it's not sticking. Damn, this wire's hot. You know why? You know why it's not sticking? Because this wire is badly oxidized. I'm going to cut this bad bit off. Let's start with some fresh bit. Freaking warm. Right. This wire is from... I bought this wire in the 1990s. Ouch. Ouch, it's friggin' hot. Right. It's a bit long. Ouch, it's bloody hot. Ah! Cut that bit off. Got a bit too much on it. So, if I solder this onto here, get my heat shrink sleeving around it. The reason I'm keeping this short is because I don't want to use too much of that heat shrink sleeving because I've nearly run out. Oh, can you actually see what I'm doing? Oh, I'll put some puts on here. I need a bit more solder on my iron. I'm not J-hooking it. You know why? Because I don't have enough. My heat shrink sleeving won't go over the top. It's on there. It's on. Right. Get my heat shrink sleeving up here. Please go on. Yes. It's on. Let's see where the metal bit is right in the middle there, so wants to be there. Right, there we go. It's properly heat shrink sleeved. My meter just went out. I can use my iron to shrink it. I can also make sure with my iron, I mean my wire, just a little bit. Don't want to do too much, I don't want to melt it all. That's done. That's not moving. Right, so I got that one lengthened. I'm going to cut this down. I'm going to find out where this will reach. It'll go around the back, go on the top, it'll go anywhere where I want it. I'm just going to cut it off there. So that's that one extended, and the one at the top, this one might be okay. I think it might be long enough. I'm not going to extend this one yet. I don't know where I'm putting it exactly. Or it might need... Yeah, I think I do need to extend it. Duh! I do! I need to. Oh, no! Duh! It's in a freaking socket, innit? Just take it out. Remove it. Duh! Right. I'll just replace this piece because it's in a socket. Right. I just can't be bothered to unsolder stuff when I don't need to do, you know what I mean? Oh, I'm still zoomed in. Stupid me. I keep forgetting, sorry. Right. I'm going to tin it. The plastic always shrinks back and then it leaves the wire longer. That's one of the issues with when you're soldering wires. So I ended up chopping a bit off the end because it's too freaking long. Oh, it's still in here. Right. Ugh, where's my screwdriver? I hope I didn't solder it. No, I didn't. Sometimes I solder the wires together and stick them in because it's safer. Sometimes when you put two wires in one shit, I forgot the name of them now. You know, these joiners, right? Sometimes when you put the one wire, you screw it down, one wire gets all the pressure on it, the other wire is loose. And sometimes it's a good idea to solder both wires together and then put them in. But this isn't that critical because it's not really carrying that much voltage anyway. But all I've got to do is make sure that both these wires are nice and tight in here. This one's actually, ouch! I've got them both in the hole. And the way I do it is once I screw it down, I pull both wires to see if they come out. Right, is that, yeah, that's in. Is that one in? Yeah, that's in. They're both held in place, they're good. Right, now I've got this wire extended. I'm going to cut it off at the same length as the other one. I'm done with the purple stuff, I just need the yellow stuff, and guess what? For some reason I've used a lot more yellow than purple. I'm not sure why, but that's the way the cookie crumbles, isn't it? Sometimes you just end up using more of one than the other. It's usually when you're making antennas and aerials, you use a lot more of one than the other. And I think years ago I used a lot of this stuff for doing CB radio antennas years ago. This is too. I'm going to cut this stuff was up, this oxidized bit, because it's not easy to solder that. So my tip is oxidized again. I hate it when it spits solder and it lands on your back of your hand and it burns you. That's what just happened, and I didn't jump because I didn't want to splatter this big blob onto me. You can make things worse if you jump. Now that's all tinned. Just wipe that flux off because it's sticky. Right, so the yellow one down here and this yellow one up here. So this is output. Output from the relay, input to that board, right? So I'm going to extend this wire because it's short, and I've got to extend this wire as well. So this one first, I think. I need some heat shrink sleeving on here. It took a bit long, like still. I think I'm going to mount it on the back because it's just logical. I mean, it's silly to put it down the side. It's probably gonna. I mean, it's out of sight round the back as well, isn't it? You don't have to look at it. Can you see what I'm doing? I think you can. These wires never get hot, by the way. They don't carry enough current. Okay, that's on. Heat shrink sleeving. There we go. I'll just use my lighter this time. My fan's blowing. My fan's blowing it out. It's under the table. That's that done. Right, that's not moving. It's stuck on there, good. I want this wire about, what? Let me see a minute. So this module input is it at the top of the bottom? Where's my thingy? Oh, there it is. In case you wonder what this is, it's a magnetometer. I use it for my light. It also has a magnetic detector on it. I don't know if you've seen it before. I've used it before. But basically it detects magnets, right? So if you've got... Oop, see this magnet here? I press this red button. It detects the magnetic field, look. Oh, the battery's gone flat. No, it hasn't. It detects magnetic fields. I need to change these batteries at some point because I've been using the torch on it a lot. Okay, so how long... Oh yeah, I was just trying to work out input, which is... Oh, I need that torch again. Input is... I marked it, didn't I? Output, input. So input's at the top, which means that when I mount this on the back, input's on the right hand side, and this wire, this yellow wire, has to come around here to here. You know, I didn't even need to extend that. Oh yes, I did. It was about an inch short, but it's going to be just right now. I'll cut it there. So if I cut this wire right here, it'll be long enough. It was about 2 inches short, but now it's okay because I've added this much on, so it's going to be perfect. Now the output is on the other side, because with the heatsink facing this way, the output is going to be... Where's the output wire? I've forgotten now. Where is it? Oh, it's down here. Right, so the out... Oh, actually... No, yeah, I've got to make this longer. It's too short. Right, the output wire is going to have to be extended quite a bit. It's right down here. you know what? I've got to extend that red wire as well. Oh, hang on. Do I? No, I can stick the red. Oh, I don't have to extend this red. This, you see this tiny red wire? It's a sense wire. I can just stick this red wire in the same hole as the white wire goes. I think. I think so. Yeah, I can just stick it in that hole and it will do the same, because otherwise I have to extend the red wire to go to the end of this. Well, I don't want to be doing that, so I'm just going to stick that. Yeah, I've forgotten where that red wire goes actually. Yeah, it's been a while since I built this thing. It's over 10 years ago. I can go and watch all my videos that I made 10 years ago, but I don't want to do that because I've forgotten it. I just want to, yeah, make life easy. So yeah, I can make this, I can just stick this red wire in the same hole as these, the white wire and this yellow wire. Let's just do that. I'm going to get my decent screwdriver for it because the other one's not very good. This electric screwdriver that I've had years, the ends have got a little bit, the tips got rounded a bit. It's not perfectly flat anymore, so it doesn't bite into the screw head as well as this one. This is a fairly new set of screwdrivers with adaptable tips on. This is what a magnetic, it holds it in place with a magnet as well. I like this one. So if I undo this, I don't want to undo these wires because they're right fighting about getting them all evenly held in place. So when I loosen this wire, it might fall out. But I need to stick the red wire in here. Oh, the white one's falling out now, look. So if I, actually if I twist the red wire and the white wire together, I can stick them both in. They don't carry current, they're just sense wires, these. Well, I'll just twist that on there. Where's my pliers going? A few microamps or whatever travels through them. I might solve these two together. Right, the red wire and the white wire are now connected together, right? So that they don't slip out. I am going to solder them together. Oh, my tip's gone a bit funny again. A bit of flux. Oops. I'm melting the insulation a bit on the red wire, but okay, they're soldered together now, so they won't slip. They make good connection. I normally switch my soldering iron off when I'm not using it, but I am using it, so. Right, now stick that. I hate these freaking covers, they keep coming up as pliers. I glued them on once, they didn't stay. Right, get this in the hole. It might be better if I just pull this wire out actually and stick the little one in first. Oh! Dropped my wire. This is what I was afraid of. There's a diode going across there. It does back feedback. So when the relay is in, no matter which direction the relay is in, that side pole or the other pole, this relay always sends a voltage through to this end. And that's because the MPPT always needs to have a voltage going to it. That's what the diode's for. But it doesn't technically carry any current until it actually gets to a certain threshold, about what, 13 volts or something. But it needs to be kept alive basically. If it's not kept alive, it goes to sleep. And if it goes to sleep, it doesn't do nap all. I just remembered why that diode was there. It's just some kind of weird, stupid redundancy thing that they built in. I can't get this freaking wire in the hole. Why can't I get the freaking... Let me just check, see if I've got that thing open properly. Oh, I see. I'm trying to push it in the top instead of the bottom. It's got to go down a bit further. That's it. That's... Get that down there, then get this. This is why I hate taking wires out of this thing, because absolute freaking pain in the neck. I need to open that contact up because it's crushed, it's been squished a bit. The screw squishes it down, then you can't get nothing in. So I'm pushing my screwdriver in to open the contacts a bit. Because they're like a little claw thing. And when you push the when you screw it in, it pushes the claw down, and the claw stays down even when you unscrew it, and you can't get the damn wire in. That's why I hate these things. They're bloody crap. Got the right one, yeah. Right, get in there. Get in there. Right, are you in? Yeah, I'm pulling this wire and it's not coming out, so it's in. Pull this wire. Yeah, it's in. So that wire's secured. It's not coming out. It's nice and tight. So that's sorted that out. So one wire, this white wire, is the trigger pulse for the counter. This is the white wire, it triggers the counter. And the red wire goes off somewhere else to trigger somewhere else. I forgot what the hell it was for. Well, I can't remember. Oh, it comes around here, look. There's a red wire, look. Comes around here. Comes around here. This is the red wire. Ah, comes all the way up to this module I built. Ah, that's it. It turns this transistor or something. There's a transistor in here, right? It's dusty. There's a transistor down here. That red wire comes in, triggers this transistor to switch power on to the relay. Ah, I remember now. Do long time. Right, that's it. That's what it's for. Without that, the relay wouldn't get energized or something. It wouldn't get power. It basically turns power on for the relay circuit. So the relay circuit is disabled when there's not enough voltage to enable it, right? So when it gets to a certain voltage, it drops. There's no power to this board at all. until it gets to a certain level, and that's when the red voltage from here goes to this relay circuit. All it does is trigger this relay circuit and this 555 timer. The capacitors are there to prevent any transients. They're permanently connected across the input of the relay, and yeah, that's it. Oh god, this is so freaking dusty. I need to go on. Where's my little brush? I've got my mini Hoover vacuum. That's better. Sorry if that blasted your ears out. Sorry about that. I can't help it. That's better. Look at all that crap. It's all gone now. It's just dust. I mean, I don't dust this thing ever. If I was to go around dusting my electronic stuff, I'd be there till the cows come home. Right. Okay. So this wire is extended. This wire needs extending. You know, I'm gonna make a part 3 of this live stream because it's crazy. Oh, I'm not as fast as I used to be. I think I'm gonna have to. Let me just check. How long have I been online? It didn't tell me. Let me just see where the hell am I? What is it? Didn't tell me. What? Oh, I see. I've been online 1 hour 22 minutes. It's right at the bottom of the screen. I didn't see it. 1 hour 22 minutes. I'll tell you what. I'm going to end it at 1 hour 30 minutes because yesterday, did a live stream. It was 1 hour, nearly 2 hours. That's too friggin' long. So I'm going to get this other wire extended. So this thing has to be input on the left, output on the right. So that wire, this other wire on this side here, has to go all the way around. So I need about 6 inches of wire on here. Right, so I need another 6 inches of wire. I'll straighten this out, it's bent. Okay, so I would say about that. About this much extra wire is more than enough. But I'm not going to cut it yet because I have to put my heat shrink sleeving on, and if I stick it on a bit of wire, it's going to fall off the end, right? So I'm going to leave it attached until I'm ready to cut it. Right. You're probably going to tell me off. You're probably going to say, well, why don't you just unsolder this off there? Well, yeah, I could do that, but honestly, it's just wasting more wire, isn't it? I'm just going to end up chucking this in the bin. I'd rather just make it longer. And this other wire, this vinyl wire, I've had it for years. It needs using anyway. The soldering iron is still awake. Surprise, surprise. Oh, he's wiping. Right, that's that done. Hot. Put that a bit more on there. Don't want to melt the wire. I don't think you can see what I'm doing. Well, yeah. Oh, this wire's in the way. Ugh. You know why it's not sticking very well? My fan is blowing on it. And I can't keep my freaking arm still. I think it's on. Yeah, that's on. Right. That is definitely on there. That's a good join. Oh, damn it. Guess what I forgot to put the heat shrink sleeve in on. Never mind. I want another 6 inches, right? 6 inches. Right, that's it. I won't put my heat shrink sleeve in on. Good thing the other end wasn't attached to anything. That would be cool. That would be a nightmare. I'd have to unsolder it again if it wasn't. Right. It's on. Now, the trouble is my fan is blowing cool air on me because I'm so freaking warm, right? And it's under the table. Now, I'm going to make sure this wire is completely covered. And every time I use my lighter, it's blowing the flame out. So if I lift it up a bit, maybe I can do it that way. I'll have to use my soldering iron. Yeah, that's definitely done. Right, all ready. Okay, I'm all ready now. I'm going to solder these wires onto the unit, and then I can mount this unit later on when I've tested it. I want to make sure it works. I'm just going to leave it dangling for now, but at some point I'm going to secure it to the back. I'm not going to use hot glue because this might get hot, right? It melt. But I'm going to use some Kapton tape. Now, for anyone that doesn't know what Kapton tape is, it's heat proof. Right. It's spelt with a K, by the way, not a C. It's C. It's KAPTAN. It's high voltage, high thermal resistance. It's basically made out of. I think it's polyamide. I think it's made out of polyamide, which is not like sellotape, which is. Yeah, well, it's not sellotape, it's Kapton. It's made out of different material. It's thermally resistant, right? So, for example, if I get my soldering iron, which is on at 300 degrees Celsius, oh shit, I've just turned it off again. It was at 300 degrees, I've just reset it by accident. I mean, it's set to 400. 380 degrees Celsius, right? Now, if I try to melt this with my soldering iron, it's resistant to fire, right? It should not shrivel up. See how resist? Oh, I'm off camera. See my temperature there. 380 degrees C, right? If you're watching my soldering iron and I touch this Kapton tape, you see it's fire resistant. It doesn't shrivel up like sellotape. You see that? I'm touching it. It's heat proof and it's also high voltage resistant. Now, I'm touching it. Look at that. Now, if I was to get some sellotape, I happen to have some sellotape kicking about somewhere. Where's my sellotape gone? It's sellotape. I think it's, is it cellulose or something? Can't see my sellotape now. Now I need it. Where are you? Where have you gone? Oh, it must be in the other room. Hang on. Right. This is sellotape, right? Everyone knows sellotape. Now look at the difference. What's this? Oh shit. Oh, I've got enough off to test with. So can you see this sellotape? Can you see it? Now if I stick that next to my soldering iron at 380 degrees C, what do you think is going to happen? Watch this. It melted, look. See that? Shriveling up. It's melted, look at that. It made a sticky mess, a sticky ball. That's why you do not use sellotape for electronics, because it is dangerous. But when you use Kapton tape, completely different. It doesn't melt. 380 degrees Celsius. That's 3 times the boiling point of water, right? Actually, it's nearly 4 times. Let's go up to 400 C. Now I'm at 400 degrees Celsius. That is 4 times boiling point of water. Right. And look at, oh, that's off camera. Look at that. I'm flicking it. See that? Now you know why. I've unplugged now. Shit. I'm going to have a break. It's, I've been live now since 1 hour 35 minutes. I'm going to have a break. My coffee's gone cold. And there's some video links in the description to when I first built this thing years ago. But unfortunately the quality is, yeah, it's not HD, it's not high definition. I filmed it on my freaking phone. Do you want to know what phone I filmed it on? Ugh. So, when I filmed the videos over 10 years ago, I was using this bloody thing. It's a Nokia. And guess what? Oh, wrong button. It still works. There's no SIM in it. Yeah, I still got it. I keep it on charge occasionally because batteries deteriorate if you don't. You might have actually heard me unplug it from the computer. Okay, I'm having a break. I will see you later.